Good morning, one and all present here. Today, I, Burhan and Moiz, along with my friend Moiz Bindawala, under the guidance of Mrs. Aksma Mukashi, are here to present a topic as to why and how aldehydes and ketones are different from each other. So let's start. So first, I would like to introduce you to the topic. First, what are the basic difference between aldehydes and ketones? First, aldehydes are type of compounds which have a carbonyl compound and the carbon is also attached to the hydrogen and to the other RH group, R group, which means an alkyl group. Whereas in ketones are type of compounds which have a carbonyl group and the carbon is attached to the R group and R dash group.
Now, let us look on why aldehydes and ketones behave differently. We all know that the difference between aldehyde and ketone is that the presence of a hydrogen atom attached to the carbon-oxygen double bond in the aldehyde. Ketones don't have that hydrogen. Instead, ketones have another R group which can be any other substituent attached to it. This is the main reason why aldehydes and ketones react differently and behave differently.
So our next subheading is why do aldehydes and ketones behave differently? So this is a subheading which is very important to know in the difference between aldehydes and ketones. So let's start. So the in aldehydes, the on one side of the aldehyde there is a hydrogen bond, whereas on the other there is an alkyl bond. Whereas in ketones there is no hydrogen bond, on both sides there are alkyl bond. That makes a difference. So the presence of that hydrogen atom makes aldehyde very easy to oxidize. That is, they are strong reducing agent. Because ketones do not have that particular hydrogen atom, they are resistant to oxidation, and only very strong oxidizing agents like potassium manganate solution, potassium permanganate solution oxidize ketones. However, they do it in a destructive way, breaking carbon-carbon bonds. Provided you avoid using these powerful oxidizing agents, you can easily tell the difference between an aldehyde and a ketone if you use a normal oxidizing agent. Aldehydes are easily oxidized by all sorts of different oxidizing agents, whereas ketones are not.
Let us now have a look at some of the distinguishing tests between aldehydes and ketones. First of all, tolerance test. Here we have shared a video of tolerance test being conducted. Let us now have a look on it. First of all, materials required. First, organic compound. Second is silver nitrate solution. Third is our dilute NaOH. Fourth is dilute NH4OH. And test tubes. Test tube droppers and a water bath. The procedure is as follows. First, silver nitrate is taken and inserted into the test tube. And add small drops of dilute NaOH is added into the test tube. There is a reaction between these two chemicals. Now, excess of dilute NH4OH is being added into the test tube and it is being shaken well. Now, 2 drops of organic compound is being added into the test tube. And now it is kept in a water bath for some time. Here is a reaction what exactly takes place in the tolerance test. We can see a silver mirror appearance in the test tube. This test is only for aldehydes and it gives a positive test for aldehydes. Ketones do not give it as a positive test.
So the next distinguishing test between aldehydes and ketones is the Felling's test. So what is the Felling's test? Felling's solution and Benedict solution are variants of essentially the same thing. Both contain complex copper ions in an alkaline solution. Felling's solution contains copper 2 ions complex with tartarate ions in sodium hydroxide solution. Complexing the copper 2 ions with the tartarate ions prevents precipitation of copper 2 hydroxide. Now the Benedict solution contains copper 2 ions complex with citrate ions in sodium carbonate solution. Again, complexing the copper 2 ions prevents the formation of a precipitate, this time of copper 2 carbonate. So both solutions are used in the same way. A few drops of the aldehydes or ketones are added to the reagent and the mixture is warmed gently in a hot water bath for a few minutes and then we can see the results.
Let us now look at the differences in the reactivity of aldehydes and ketones. First is addition of alcohols. In the cases of aldehydes, they react with alcohols to form an unstable product which is called as hemiacetals, which further react with alcohol to form acetals. While in the case of ketones, they do not react with alcohols to form corresponding hemiketals and ketals. Below you can see the reaction which forms hemiacetal with aldehyde.
The second difference in reactivity in aldehydes and ketones is reduction. So aldehydes undergo reduction to form primary alcohols, whereas ketones undergo reduction to form secondary alcohols. So as you can see in the diagram, first an aldehyde is hydrogenated to form a primary alcohol, and in the second you can see a ketone is hydrogenated to form a secondary alcohol. So why is it so? Because an aldehyde has already got one alkyl group and a hydrogen bond. So when the hydrogen adds to it, it forms a primary alcohol because there is only one alkyl attachment. Whereas in the ketone, after hydrogenation, there were already two alkyl groups and one hydrogen is added. So there are total two alkyl groups added to the carbon atom. So it is a secondary alcohol.
At the end, let's have a comparative study between aldehyde and ketones. First of all, let's start with the definition. As you all know, aldehyde is an organic compound having the general chemical formula RCHO, while ketone is an organic compound having the general formula RCOR. Functional group. The functional group occurs always at the terminus of the molecule, while in ketone it always occurs in the middle of the molecule. Location. The carbonyl-carbon binds with the hydrogen atom from one end, while carbonyl group binds with carbonyl atoms from both the sides in ketone. Nomenclature. Aldehyde has the suffix al, while ketone has the suffix one. Reactivity. Aldehydes are more reactive than ketones, while ketones are less reactive than aldehydes. Oxidation. The product of oxidation of aldehydes is carboxylic acid, while ketone does not undergo oxidation at all. Occurrence. Aldehydes occurs mainly as volatile compounds, while ketones occurs as sugars.